this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over some more limit definition derivative examples, this time with quadratics as our original equations. So just like linear equations, we're just going to use this general form of the limit definition of a derivative and plug in everything we have already. So if our f of x is x squared plus 2x plus 1, then our f of x plus h will just be that, but with x replaced with x plus h. So we've got x plus h squared plus 2x plus h plus 1 all over h. And then we also have to subtract the original f of x on the top. So we've got x squared plus 2x plus 1. So our first step here is to simplify the top. So we're going to have to expand this out and distribute this 2 through. So if we take the limit of h approaches 0 of, if we expand this x plus h squared out, that gives us x squared plus 2xh plus h squared plus distributing this 2 to the x and the h plus 2x plus 2h plus 1. And then I'll distribute this negative to all three of these pieces. So minus x squared minus 2x minus 1 all over h. So now we want to try to combine like terms as much as we can. So here we've got an x squared minus x squared, so these will cancel each other. We have a 2x and a minus 2x, so these will also cancel. And then we have a plus 1 and a minus 1, which will cancel each other out. So our limit, as h approaches 0, we're left with 2xh plus h squared plus 2h on the top, and we're dividing by h. So since all three of these terms in the top have an h in them, and we're dividing by h, we can cancel 1 out from each of the terms. So we still have our limit as h approaches 0. Now we've got 2x plus 1h plus 2. And now we just plug 0 in for h right there. So our derivative in this case is just 2x plus 2. Now moving on to the next problem. It'll be similar to the last one we just did, just with some different numbers. So once again, we're just going to do the f of x plus h. So everywhere there's an x, we're replacing it with x plus h. So we've got 3 times x plus h squared plus 5 times x plus h minus 2. And then remember, we have to subtract f of x. So minus 3x squared plus 5x minus 2 all over h. So just like the last one, we're just going to simplify this stuff out. So we've got the limit as h approaches 0 of 3 times x squared plus 2xh plus h squared, that's an h, plus, we'll distribute this 5 through, so we get 5x plus 5h minus 2, and then I'll distribute this negative to all three of these again. So minus 3x squared minus 5x x plus 2. And again, still all over h. So I'll work on distributing this 3 in here. We've still got that limit on the outside. The limit as h approaches 0 of 3x squared plus 6xh plus h, or 3h squared, sorry, plus 5x plus 5h minus 2 minus 3x squared minus 5x plus 2, and still over h. So now we'll combine like terms just like the last time. So we've got this 3x squared minus 3x squared, which will cancel. then we've got this 5x minus 5x, which will cancel, and this negative 2 plus 2, which will cancel. So we're left with the limit as h approaches 0 of 6xh plus 3h squared plus 5h divided by h. So now, again, since all three of these terms have an h and we're dividing by 1, we can cancel 1 from each of these terms out, which leaves us with the limit as h approaches 0 of 6x plus 3h plus 5. So once again, we're going to plug 0 in for h, which will get rid of this term, and it leaves us with our derivative as 6x plus 5. And this is our final answer for the derivative. So yeah, the same process as the linear examples, just a little bit more complex with the x plus h squared being thrown in there. Your main goal is just to get everything simplified on the top and then divide by h and plug 0 in for h at the very end. So yeah, that's about it. Thank you for watching.